Okay, in this unit we're going to be looking at acceleration, and to understand acceleration you need to understand the difference between two physical quantities, velocity and speed. Now, they're often used interchangeably, but they are different. Velocity and speed are both measured in the same unit, meters per second, but there's a difference between them. So let's first of all consider speed. If you are driving along in your car, and you are looking at your speedometer tells you the distance you have travelled in a given time, so the speed that you are travelling, because speed equals distance divided by time. So it's actually measuring this from your wheel, so it knows the radius of the wheel. It can work out how many times the wheel has gone round, so the distance you've travelled, and it does that continuously, and so it tells you your speed, instantaneous speed, as you are going along your journey. Now, the thing about speed is it doesn't take into account which direction you're going. If you're in a car, okay, you can drive in a very zigzaggy or wiggly path, okay, and your speed could stay constant for this whole journey. So if you're looking at your speedometer and you're following this funny wiggly path, okay, you could keep the speed exactly the same the whole way round, so your speed is not changing. However, your velocity is changing. And I want to talk about how velocity is different. Velocity is speed in a particular direction. It's what we call a vector quantity. Now, we can represent, whenever we show velocity, we need to specify a direction, and we can do this by using an arrow. So, for example, this arrow here represents a speed to the right, okay, quite a big speed to the right. So the length of the arrow tells you the size of the speed, so the magnitude, okay, and the arrow shows you direction. So the arrow, it gives you two bits of information, the size and the direction. So this is a big velocity to the right, and this is a small velocity to the right, okay, and then this arrow is a big velocity to the left, okay, and this is a little velocity to the left. Okay, now you can see from our curvy journey in the previous one we were talking about, we can see, even though the speed stays the same all the way around, we can see that at any particular time the direction is changing. Okay, so at this point we have a direction, so the velocity is like that, and here the velocity is like that, and here the velocity is like that. Okay, the arrow doesn't change size, but the direction does. Okay, so the magnitude, the speed bit doesn't stay stays the same, but the direction changes. Okay, this means that the velocity is changing. If its direction is changing, then we say the velocity is changing, even though its magnitude stays the same. Now, in terms of our arrows down here, we are only going to deal with, when we're talking about velocity, we only deal with, at this level, with forward and backward velocity. And we usually can tell, in our calculations, we can tell the difference between forward and backward velocity, because we normally say a forward velocity is a positive velocity, and a backward velocity is a negative velocity.